Okay, so today we are looking at solving systems of equations, or the introduction to it. So this should be a review since you have already learned systems of equations, but we are going to focus more on how they are related, specifically how we can manipulate the equations, and how they will still be the same equation. So, the first question says, sorry, this is page 126, and this is also module 1, lesson 23. So, the very first opening question says, here's a system of two linear equations, and we need to verify that the solution to the system is 3, 4. So we have two different equations. We have A1 and A2, and in order to see if something is a solution to the system, we need to substitute 3, 4 into our two equations. So substituting 4 for y and 3 for x, we get 4 equals 3 plus 1. So 4 equals 3 plus 1, which is 4, and 4 does equal 4. So that tells me that 3, 4 is a solution to equation A1. Doing the same thing for equation A2, we're going to get, again, substituting 4 for y and 3 for x, we get 4 equals negative 2 times 3 plus 10. So 4 equals negative 6 plus 10. And negative 6 plus 10 also equals 4. So this shows me as well that that 3, 4 is a solution to equation A1 and A2. So starting with the next part of this lesson, we're going to look at a little exploration. So we're going to write down another system of two linear equations, B1 and B2. So B1 and B2, we're going to write two different equations. And the solution also has to be the 0.34. But this time, we're going to make sure both equations have a positive slope. So for B1, we're just going to use the same equation as A1 because it already had a positive slope. So B1, sorry, I don't know why the screen's freaking out. Anyway, B1, we're going to do y equals x plus 1 because we're going to use the same equation. But B2, we have to switch it up a little bit because A2 has a negative slope and we need it to have a positive. So the equation that we're going to use for B2 is going to be the equation y equals 2 times x minus 3, and then we're going to add 4 on the end. So this equation, again, also has a positive slope, and in order to make sure that 3, 4 is a solution, we're now going to look at part B, and we're going to substitute that 3, 4 in for both equations. So B1 is going to be really easy because we've already solved B1 before in the previous problem. But just to do it again, we're going to have 4 equals 3 plus 1, which again gives us 4 equals 4. So that shows us that B1 has the solution of 3, 4. So now we're going to do the same thing for B2. And B2, again, we changed it because it now has a positive slope. So this gives me 2 times 3 minus 3 plus 4. So I get 2 times 3 minus 3, which is 0, plus 4. 2, and sorry, I forgot to write equals 4. So 4 equals 2 times 0, which is 0, plus 4. And then this is going to simplify to 4 equals 4. So this shows us that 3, 4, even though we changed B2 to have a positive slope, it still shows that 3, 4 is a solution. So for C, we're going to graph this system. We're going to graph B1 and B2. So let's make our graph lines. And again, they're not going to be perfect, but we're doing the best we can. Okay, so if we graph B1, B1 has a y-intercept of 1. Actually, I can probably draw those a little better. Here we go. And there. Much better. Okay, so B1 has a slope of 1 and a y-intercept of 1. So we're going to graph B1. We need to graph our y-intercept first. So we're going to put a point at 1. At y is 1. Oh, it's hard with this. There we go. Put a point at y is 1. And our slope is up 1 over 1. Which is there. Up 1 over 1. Up 1 over 1. Okay, so this is my line. So this is B1. Okay, to graph B2, we still need to know the x-intercept. The slope and the y-intercept. So just to distribute and get that, we have y equals 2 times x minus 3 plus 4. So when I distribute 2, I get 2x minus 6 plus 4. And this gives me 2x minus 2. So my y-intercept is negative 2. So we go down 1, 2, and put a point. And then my slope is positive 2. So I'm going to go up 2 and over 1. So up 2 over 1. Up 2 over 1. Like that. And then we're going to connect those dots. Like that. Okay, so this is our B2. Okay, so remember, the solution to your system should be the point where they intersect. And from what we've plugged in with substitution, we should know that that point is 3, 4. But just to double check with what I've graphed, let's make sure that this point is, in fact, 3, 4. So they should equal. All right, so part D says, are either B1 or B2 equivalent to the original A1 or A2? So yes, because B1 and A1 are the same equations, right? So we didn't change anything between the two. They're the exact same equations. However, B2 is different. So B2 is different because B2 has a positive slope and A1 does not. Okay, so moving on, we're going to now look at part E. So part E says add A1 and A2 to create a new equation C1. So if we just write A1 and A2 down again so we can see those. So A1 is y equals x plus 1. So y equals x plus 1. And A2 was y equals negative 2x plus 10. So to get C1, they want us to add these two together. So if I add these two together, my C1, so y plus y is 2y, x minus 2x is negative x, and 1 plus 10 is 11. So C1 is going to be 2y minus x plus 11. Then it wants us to multiply A1 by 3 to get the equation C2. So C2 is going to be 3 times A1, which is y equals x plus 1. So C2 will be 3y equals 3x plus, not 1, plus 3, because we're going to distribute the 3 into the equation to get multiply 3 by A1 in order to get the new equation C2. So it says, why is the solution to this system also 3, 4? So, we know that this will give us, for C2, we're going to get that the solution to the system is 3, 4, because when A1 is multiplied by 3, we did not create a new equation, we just created a multiple of the equation. Also, for C1, the same concept. So if we want to know if 3, 4 is a solution, we could always substitute it in, which we can do that really quickly. So C1, if we substitute 3, 4, that gives me 2 times 4 equals negative 3 plus 1. Plus 11. So this gives me 2 times 4 is 8 equals negative 3 plus 11, which is also 8. So we can see that 3, 4 is a solution. If we do the same thing for C2, we're going to get 3 times 4 equals 3 times 3 plus 3. So 3 times 4 is 12. 3 times 3 is 9 plus 3. So this gives me 12 equals 12. So when we are doing this, we're not changing and creating a new equation. When we made C1 and C2, we were taking what we already had and created multiples from them. Okay, so using that information, we're going to look at another example. So it says all of these equations are built off of each other. So we started with A1 and A2 up here. So we have A1 and A2. Then we created B1 and B2 from that. And then we also created C1 and C2. So now we're going to create and look at, or we're not creating, they've given us an equation D1 and D2. And all of this, each equation, like D1 is the same thing as A1 and B1. And D2 is the equation that's slightly different. So it says the following system of equations was obtained from the original system by adding a multiple of equation A2 to equation A1. So it says, part F says, what multiple of A2 was added to A1 to create D2? So we took A2 and we multiplied that by 2. So again, if we look at A2, so I'll rewrite A2 for you. So we'll write it up here. A2 is y equals negative 2x plus 10. Plus 10. So again, we're looking at what did we do to A2 and then add to A1 in order to get D2. So A2 starts with 1y and A1 also starts with 1y. But D2 has 3y. So I need to multiply A2 by something that I can add 1 to in order to get 3. So if I multiply A2 by 2, so if we multiply A2 by 2, that gives me 2 times y equals negative 2x plus 10. So simplifying that, we get 2y equals negative 4x plus 20. Okay, so I multiplied everything by 2. And then if I multiply that by 2 and then add it to A1, 2y, so if we write it, so 2y equals negative 4x plus 20. And we're going to add that to y equals x plus 1 because we're adding it to A1. 2y plus y is 3y. Negative 4x plus x is negative 3x. And 20 plus 1 is 21. So that's how we get D2. We took A2, multiplied it by 2, and then added that to A1. So part G says, what is the solution to the system of two linear equations formed by D1 and D2? So what we could do is we know that these equations are found by manipulating A1 and A2. So if the solution to A1 and A2 is 3, 4, then let's check to see if the solution to D1 and D2 is 3, 4. So D1 again should be simple. We should already know if that's a solution because again it is the same thing as A1, B1, and so on. So again, plugging in 3, 4, we're going to get 4 equals 4. So that tells us that D1, of course, has the solution 3, 4. But now let's look at D2. So looking at D2, we're going to plug in 3, 4. So 3, plugging in y, which is 4. So 3 times 4 equals negative 3 times 3 plus 21. So 3 times 4 is 12. Equals negative 3 times 3 is 9. Negative 9 plus 21. And then 12 equals negative 9 plus 21 is 12. So then this tells us that 3, 4 is a solution to D1 and D2. Okay? So part H says, is D2 equivalent to the original A1 or A2? So D2 is not, not equivalent. And it's not equivalent because D2 has a slope of negative 3, and A1 and A2, first off, A1 has a slope of positive 1, and D2 has a slope of negative 2, and there's nothing we can do that will give us that because, like I said, D2 has a slope of negative 3, and so then they're not multiples of each other. All right, so moving along, part I, start with equation A1, multiply it by a number of your choice, and add the result to equation A2. This creates a new equation A2, and then we're going to check to see if it is a solution. So I'm going to pick a random number, and we're going to make it 3. So I'm going to multiply A1 by 3, and then we're going to add that to A2. Okay? So A1 is y equals x plus 1, and I want to multiply this by 3. because that's the number that I picked. So this is going to give me 3y equals 3x plus 1. So after I multiply by the number of my choice, it wants me to add that result to equation A2. So 3y, so we'll come over here. 3y equals 3x plus 3. I'm sorry, this should be a 3. 3, and I'm going to add that to A2. So A2 is y equals negative 2x plus 10. Okay, right. A2, just to make sure, is, yes, y equals negative 2x plus 10. So adding these two together, this is going to give me my new equation, E2. 3y plus y is 4y. 3x minus 2x is 1x. And 3 plus 10 is 13. So my new equation, E2, is 4y equals x plus 13. Okay, and then it wants us to check to see if 3, 4 is a solution to my new equation E2. So 4 times y, which is 4, equals 1 times 3 plus 13. 4 times 4 is 16. 1 times 3 is 3 plus 13. So this gives me 16 equals 3 plus 13, which is also 16. So we can see here that the new equation that I created also has the solution of 3, 4. So since E1 and E2 both share the same solution, that means that E1 and E2 is a system. All right, so let's look at an example of taking two equations with a system and then finding the solution instead of substituting a point. So we have a system that has two equations. The first equation is 2x plus y equals 6, and the second equation is x minus 3y equals negative 11. So in order to solve the system, I'm going to use elimination. So in order to eliminate, we're going to do the same thing we kind of just did up here, where we're going to multiply one of the equations by the other and then add them two together. So when we eliminate, we need to be able to cancel one of our variables. So I want to cancel the x. So my first equation has 2x and my second equation has just x. So I can multiply this second equation by negative 2. And when I multiply by negative 2, that's going to give me a negative 2x at the beginning. So when I distribute the negative 2, we get negative 2x plus 6y equals positive 22, because negative 2 times x is negative 2x, negative 2 times negative 3y is a positive 6y, and negative 2 times negative 11 is positive 22. So moving both of those over here, so 2x plus y equals 6 was my first equation. My new equation after we multiply by negative 2 is negative 2x plus 6y equals 22. So now I want to solve it. So since we've multiplied one equation, now I'm going to go through and I'm going to add everything together. So negative 2x minus 2, positive 2x minus 2x, whenever I add those two together, they cancel each other out. Y plus 6y gives me 7y equals 6 plus 22 gives me 28. And then from here, we're going to solve it just like we would a single variable equation. So I'm going to divide both sides by 7. The 7's cancel here, and I get y equals 4. So y equals 4 is half of my solution. I still have to find what x is equal to. So in order to find what x is equal to, we're going to substitute this y in for either one of my original equations. So I'm just going to do the first one. So 2x, substituting 4 for y, we get 2x plus 4 equals 6. And then we're going to solve for x. So I'm going to do the inverse operations. I'm going to subtract 4 from both sides. So 4 minus 4 cancels. I bring my 2x down, equals 6 minus 4, which is 2. Then we're going to divide by 2 in order to get these 2's to cancel. And this gives me x equals 1. Okay, so again, this is the other half of our solution. So this tells us, after solving, that the solution to this system is the 0.14. So again, if we think about the very first question we did with the graph, if we were to graph these two equations, the point where they intersected would be at the 0.14. Okay, so we're going to do one more together, and then I'm going to have you do number 2 by yourself. So number 1, we're doing the same thing. We need to solve the system to find x and y. So here for the second one, I have the first equation is 2x plus 3y equals 7. And then my second equation is x minus y equals 1. So we're going to multiply. I'm going to multiply the second equation, because if I multiply the second equation by 3, I'm going to be able to cancel my y values. So distributing the 3, we get 3x minus 3y equals 3. And so again, we're doing that because we want to cancel either the x or the y. So rewriting the first equation, 2x plus 3y equals 7. And now writing our new equation that we multiplied by 3, we get 3x minus 3y equals 3. And just like we did in the example above, we're now going to add these two together. So 2x plus 3x gives me 5x. Positive 3y minus 3y cancels, and then 7 plus 3 is 10. And then from here, all we have to do to get x by itself is divide both sides by 5. Makes these 5 cancel, so I get x equals 2. So x equals 2 is the first half of my solution. To find the second half, we're going to substitute x equals 2 into either equation. I like to choose the smaller equation because it takes less time to solve. So I'm going to take my second equation and I'm going to plug in 2. So 2 minus y equals 1. Subtract 2 from both sides, and we get negative y equals negative 1. Then we have to get rid of the negative with the y. So I'm going to divide both sides by negative 1. So negative 1 divided by negative 1 is a positive 1. So then that tells me my solution to exercise 1 is the 0.21. And again, thinking about it in a graphical sense, if we were to plot both lines, the point where they intersected would be the 0.21. Okay, so I want you to solve the very last question here, and then we will check it whenever you come back to class.